portable solar power chargers. It is mainly in the portable solar chargers, the rectifier plays a vital role. As we know, the rectifier mostly it divided into three types mainly, which is full wave rectifier, half wave, and silicon control based rectifiers. And the one of the major applications of rectifier will be used in voltage regulator circuits, as well as it is used in power fluctuations, and also it is used in electroplating circuits, as well as it is used for waveform shaping circuits. Today we are going to mainly discuss about the portable solar power chargers in the design thinking approach. In the each stage we are going to elaborate this topic, and let's take a few more minutes to discussions, and we can start our presentations.
In the pain points, unstable voltages from direct solar panels damages those devices, and power banks often fail due to overcharging on unreliable inputs. Devices cannot be used during bad weather due to the lack of power backups.
So design is the phase of design thinking where you clearly articulate the problem you are trying to solve. In this, users in off-grid rural area need a reliable, weather-resistant and a safe way to charge essentials electronic devices using solar power. The design requirements are convert a solar DC to stable DC using a rectifier and a voltage regulator, store power in batteries for a night use, and have a user-friendly interface for like basic induction, like charging status, etc.
Start.
Prototype, low fidelity prototype, circuit with a solar panel feeding into a rectifier, which includes voltage regulator, power output via USB and a 12 volt port, indicator with basic LEDs, case using 3D printed or reused materials, for example wood and plastic, high fidelity prototype, enclosed case with foldable solar panels, sealed circuit board with rectifiers, batteries and regulator, multiple devices charging simultaneously, mobile app which is optional to monitor voltage and.
Let's say about the testing phase. In our testing phase, we want to test whether our charger is working efficiently under the real life conditions. So we tested it using the both solar energy and the AC power input to see how well the rectifier and the voltage regulator perform. First, we started the first day with the testing under the bright midday sunlight. The output voltage is steady at 5.1 volts, which is very perfect for charging the devices. The phone was charged up to 50%, which is very efficient for charging the devices. Then next day we tested it under the cloudy day. The input was very weaker. The voltage dropped to 4.3 volts, which is not sufficient for devices to charge. So we realized that we might use the MPPT controller to improve the performance of the device in the low light conditions. Next, we also tested it using a AC input. So the full wave bridge rectifier is smoothly converts the AC into DC. The voltage is steady at 5 volts, which is sufficient for the devices to charge. So there is no heat generation, so the cooling system is not required for that. Next, we also connected the two devices simultaneously. The voltage is dropped to 4.8 volts, but it also in the safe charging zone. So there is a little warm in the regulator, but it is also not considering. Then we also check the durability of the charger by conducting a drop test at 1 meter. The case got a little scratches, but its inner component is not damaged. So the phone runs smoothly. We conducted a user test by providing the prototype to the users. They might give the feedback like it is very easy to carry and it's very simple, useful and very useful for them. They mostly highly rated it for its portability and functionality. Based on the results, we identify a few areas of improvement. We plan to add MPPT technology, include battery level indicators, and design a more rugged and water resistant casing to enhance real world performance.
On saying the ideal part, the main motto of the ideal part is to generate creative ideas for the given problematic solutions, for generating a new innovation from the ideas. So that here we use a full wave rectifier which has been connected to a AC backupping charger from the generator and the grid system, where where it has been combined with a DC to DC converter for solar power input, and it's also been added with a USB port with over voltage protection to protect it from the over voltage and short circuit during the current supply in the charging point. Next, it has been also added with a small LED light for indicating whether the system is being on or off on the same system. And some of the brainstorming features that has been used in this rectifier based solar charging unit is foldable solar panels for the reliability and portability, and it is also has a shockproof case, and it is also has a battery level indicator to indicate how much of the battery percentage has been there in the charger. And next, it also has extra multiple ports for getting the output from the USB port, for example 12 volt USB in DC supply.